Hello students. Now let me take a topic, mole concept in chemistry. So what do you mean by a mole? Mole is actually nothing but it is a quantity of some particles. Particles in the sense we can take like a small particles, exactly we can say, because in order to measure big particles, say just we can take some examples like your apples, banana, some vegetables or fruits. If you can take, we'll have some other measurements are there like grass or a dozen, half a dozen. Like that we have some measurements are there here. But when you want to take like a very small particle such as like electrons, protons, neutrons, okay, atoms, these are all actually invisible. We cannot able to take the particles, we cannot able to count the particles also. That's why we need another quantity which is actually very big number we have to get when you take one a small quantity like 1 mole like that. So mole is nothing but you can say it is a quantity which can in order to measure the smallest particles here. So according to that particular case here, mole when you are taking here, so in this some number of particles will be there. As I told you, like in a dozen this and there are 12 particles are there, like 12 bananas, 12 apples, like that. Similarly, a mole is also should contain some particles. Then how many particles will be present? So separately they have calculated that mole is nothing but you can say in this particular mole there are Avogadro number of particles will be present. What do you mean by Avogadro number of particles? How they measured? So the number of particles which are present in the mole must be equal to like 12 grams of like one C12 isotope here. In that how many particles are there? The same number of particles which are present in that particular 1 mole here. So in this they found that here the number of particles that is represented as Na, which is nothing but 6.022 into 10 to the power of 23 particles. This is per mole. So these many particles are there per mole. That means, for example, if you take like electrons, 1 mole of electrons in the sense these many electrons, 1 mole of protons, these many protons, 1 mole of neutrons, these many neutrons, like that. So the mole is nothing but you can say one particular quantity we have taken. This is in terms of what you can say the particles. Now let me take with respect to another unit. So mole can also measure with respect to volume, mass as well as particles. Now let me check how it will going to work with respect to other cases. Say mole can be expressed in terms of mass or weight, and in terms of like volume, and in terms of particles. There are 3 measures we can able to take here. What are they? Mass, volume and particles. Then how to calculate the number of moles if mass is given to you? Okay, or if mass, if you want to calculate number of moles has to given. What is the relation between mass and moles? If you take in that particular case, the number of moles usually represented as like you can say n, small n. So number of moles will be given as with respect to mass. If you can consider here the mass by the molar mass, So mass or the given mass by its molar. What do you mean by molar mass here? The molar mass is nothing but you can say the total mass of the substance. Say for example, if you can consider like here H2O, in that you have to add all the atomic masses. I think you are aware of this atomic masses. Hydrogen atomic mass originally we can consider like 1.008, and for normal calculation we can approximately taken as 1. And oxygen can be taken as like actually 15.99, which is approximately taken as 16. So in that way when you take H2O molecule, if you can consider its molar mass will be 16 plus 2, 18. So when you take, if any mass of some H2O is given to you, then how to calculate number of moles means the given mass by 18. If you can do, we're going to get the number of moles. Like that, any particular compound mass if they provided to you, so anyway the substance they are going to give to you, so that particular substance molar mass we should calculate, then we can able to proceed to calculate the number of moles. That is with respect to mass. Now we can take with respect to volume. Volume, how to calculate? So when you want to calculate the number of moles with respect to volume here. So the given volume or the volume of the substance which they provided by 22.4 liters. 22.4 liters if volume is taken in the liters, or the volume can be taken in terms of ml, in the sense volume taken in ml by 22,400 ml. So depending upon the given data, we have to change. That means if the volume is given in ml, you can divide it with 22,400 ml, and if the volume is given in terms of liters, you can just take 22.4 liters. Why we have taken 22.4 liters? Here we usually measure this particular molar volume, we can call it as, say 1 mole of any gas can occupy certain volume, certain fixed volume. You can send any one particular gases here, 1 mole if you can consider, they can occupy certain space, certain volume. That is actually they measured as 22.4 liters here. So therefore, we have to divide it by its molar volume here. So they are going to provide you in the question like the volume of the substance. Say for example, some 5.6 liters of O2, something they mentioned here. So how to calculate the the number of moles here? So what is the given volume? 5.6 they given. 5.6 by 22.4. So it becomes 1 by 4, which is nothing but 0.25. So in that way we can able to calculate the number of moles if volume is given. Or if number of moles is given, how to calculate volume also we can able to use the same formula. Because in this number of moles, volume and 22.4, 22.4 is fixed actually. The volume and number of moles are variables. In these two, anyone they are going to provide you another value you have to calculate. Even in case of mass also same way. Mass, number of moles. These two are only variables. Molecular mass for a substance is fixed. Therefore, as it is a constant, mass or number of moles, any one of the, if they will provide you also, the other value can be calculated easily. Okay. Similarly, let me consider like number of particles. If you want to calculate the number of particles, that means number of moles with respect to particles, number of moles is equal to given number of particles by, as already we discussed, 1 mole of any substance can occupy Avogadro number of particles. Therefore, we can able to take Na value, or we can also write in the form of Na 6.022 into 10 to the power of 23. So the given particles are going to provide to you, and number of moles can be calculated, or number of moles can be provided to you, particles can be calculated. Like that we can able to use. This is the one step, that is case 1 we can say. There are 3 cases of mole concept problems are there here. So case 1 it is related with either mass or volume or particles. If they'll provide you how to calculate number of moles. Or other words, if number of moles are given, other thing, that is either mass or particles or volume can be calculated here. This is the first step of doing the problems, or we can also say that case 1 for doing the problem. Okay. Now let me take the second step of the problems. How to proceed second step of the problems. When you take the second step of problems here, say let us suppose, say let me consider the same way like particles are there here, and here volume is there, and what you can say, mass is given to you. So next when you want to proceed, let us suppose mass is given to you, volume they are asking. This is case 2 problems. That means case 1 problems only with respect to one case. That means either mass or volume or particles. Only once they are going to ask you. That means mass they will give you, number of moles we should calculate. Or number of moles they will give you, mass can be calculated. Next, volume will be given, number of moles can be calculated, or number of moles will be given, volume can be calculated. Similarly, with respect to particles also. Second step of problems will be, mass they are going to provide you, volume you should calculate. Or volume is provided to you, mass can be calculated. Or volume can be provided, particles can be calculated. Or particles can be given, volume can be calculated here. Okay. And next, similarly, particles can be provided, mass can be calculated, or mass can be provided, particles can be calculated. So how to proceed these particular cases? As already we studied the number of moles, here in this second step here, when you are doing the competitive exams, you no need to, like take step by step problems and all here, because we have to do like actually, we have to save the time here. So that direct formulas we can able to use. As you know that here number of moles, how to calculate with respect to particles here. I can take like here particles by Avogadro number. And mass how to calculate, that means number of moles how to calculate with respect to mass, that is nothing but you can say mass by molar mass. Mass by molar mass or molecular weight. So if you equate these two, here, then anyone, if they'll provide you, other can be calculated. Because in the denominator values, both the cases, both are constant. Therefore now again it becomes like two variables only. Either mass or particles, one of them they're going to provide you, other value can be calculated. So in that way, this is the second step of problems when we are merging two, volume and mass, or particles and mass, or what you can say volume and mass. Like that, any particular two cases will be merging. So let us suppose with respect to mass and volume if they'll provide to you. So what we can able to do here, mass, that means number of moles with respect to mass will be mass by molar mass, which must be is equal to volume. So volume by volume in terms of liters, if I can take here, 22.4 liters. 22.4 liters. So in that way we can able to. So for example, if volume is provided to you, mass can be calculated, or if mass is provided to you, volume can be calculated. In that way we can able to proceed. Now let me consider with respect to particles and volume. If particles and mass are provided, so any one of them if it is provided, let us suppose like particles by Avogadro number must be is equal to what I can take here, volume, that should be in terms of like liters, by what I can take here, the 22.4 liters I can take here. So therefore, if particles are provided, volume can be calculated. If volume is provided, particles can be calculated. Therefore, this is our second case problems in which we can able to calculate, one is provided, other can be calculated. That means if particles are provided, mass can be calculated. Mass is given, particles can be calculated. Similarly, if mass is given, volume can be calculated. Volume is given, mass can be calculated. For a particular, anyway the substance they are going to provide it to you. And particles if they'll give you, volume can be calculated. Volume if they'll provide you, particles can be calculated. So in that way, we can able to take the, what you can say, calculations in the second step. Let me take one simple example here. Say let us suppose here, if some mass is given to you, some 4 grams of sodium hydroxide they given it to you. In 4 grams of, okay, when you are taking with respect to volume here, I can take one more example. Let us suppose some oxygen you can take here. Say oxygen, some 5.6 liters. 5.6 liters of volume of O2 if they provided to you. What is the mass which can be provided, or what is the mass which can contains 5.6 liters? Let us suppose 5.6 liters of volume they provided, right? That you can substitute here. 5.6 by 22.4. That becomes 1 by 4. Now that 4 you can, so we need to calculate here mass right here. So mass will be equal to molar mass by that 4. Molar mass of like here O2 will be 32. 32 by 4 will give you answer like that. So in that way we can able to proceed here. So if what you can say 5.6 liters of O2 is given, let us suppose here, what is the mass? Mass can be calculated. How to calculate here? So volume is given right here. So what I can take here? Mass by, what's the O2 molar mass? O2 molar mass is, oxygen is 16 grams, atomic mass 16 to the 32. So 32 is equal to, volume how much is given? 5.6. It is in liters only. Therefore 22.4 I can do. So then that implies what I can do here, mass, how to calculate here mass. So 32 here, 5.6, so now it will be 4 times, okay, 4 into 8 times. That means mass you are going to get it as 8 grams. Mass you are going to get it as 8 grams, like that. In that way, we can able to calculate the mass if volume is provided. Similarly, reverse also we can able to do. This is the second type of problems and all here. Okay. So when second type of problems when you are doing here, you need a minimum 2. Either particles mass or particles volume or volume mass. Okay. Any particular relation they may ask you, they may give you, so that we can able to proceed. Okay. This is the second step of or second case of problems and all. Now let me go with the third case of problems. How to proceed? Third type of problems and all here in a mole concept. When you take about third cases of problems and all here, they're going to ask you to calculate number of molecules, number of atoms, or you can say number of subatomic particles like here electrons, protons, anything. Let me take a number of electrons in the particular sample. So they're going to give you any particular data. In that particular data, like a number of molecules, how to calculate here. So usually number of moles, number of molecules, if you want to calculate, we have the formula number of moles multiplied by Avogadro number. This is a formula here. But number of moles, how to calculate here? I given you already 3 formulas to you. Anyone you can able to use depending upon the given data. So you can see in the question, they given weight or volume or particles. Whichever they are going to give you, that related formula you can substitute and can get number of moles. You multiply with Avogadro number, you are going to get number of molecules. That's it. Now similarly, number of atoms. So number of atoms, there are 2 different cases of questions they are going to ask you. One is directly the number of atoms they are going to ask you. And second case, number of specified atoms they are going to ask you. Specified in the sense, say, for example, glucose is there. Glucose in this sense, what's the formula? C6H12O6. Okay, first let me give the formula, then after I'll take the example. So number of atoms, how to calculate? Number of moles multiplied by atomicity into Avogadro number. Number of moles multiplied with atomicity into the Avogadro number will give you number of atoms. Similarly, number of electrons, how to calculate here? N into number of electrons in that species into Avogadro number. These are the formulas here. Now let me take a simple example here. What about like number of atoms, how to calculate? I think you know about like number of molecules, how to calculate, because number of moles anyway you know, you just multiply it with Avogadro number, you'll get the answer. But when you want to do about like number of atoms, how to proceed? What do you mean by atomicity? Atomicity is nothing but the number of atoms present in a molecule. Say as I have taken like C6H12O6, this is glucose. C6H12O6, this is glucose. So in this glucose, say for example here, if they'll ask you to calculate, say for example here, so 18 grams of glucose is given. 18 grams of glucose is given to you. How many number of atoms are present? How many number of atoms are provided to you? So how to calculate number of atoms in this case here? Number of atoms will be calculated as number of moles multiplied by atomicity into Avogadro number. So for this situation, for this case, number of moles, how to calculate number of moles? I told you in the given data, what is provided here? Here mass is provided. If mass is provided here, which formula we should use? Mass by molar mass. So 18 by, so when you calculate the glucose molar mass, you're going to get around 180. So 180 into atomicity. What is atomicity? I told you number of atoms in a particular molecule. Here the glucose molecule they given as what? C6H12O6. So in this 12 plus 12, there are 24 atoms are there. Therefore, that 24 becomes the what? The number of atoms or atomicity. Atomicity is the 24. Into Avogadro number. Avogadro number you know right here. What is that value? 6.022 into 10 to the power of 23. If you do that, you'll get the answer. This is how like number of atoms can be calculated. Now, second way how they're going to ask you to calculate number of atoms, a specified atoms they're going to ask you. Say for example, so instead of asking like number of atoms in 18 grams of glucose here, so same calculation of number of which atoms, like hydrogen atoms specifically they asked. Let us suppose calculate the number of hydrogen atoms in 18 grams of glucose. In 18 grams of glucose, how many hydrogen atoms are present? That is a question. So in that particular case, what we should do here? So here they specifically they are asking about, you can say hydrogen. When they are asking specifically about hydrogen, you have to take atomicity. In the place of atomicity, only with respect to hydrogen we should take. What is that with respect to hydrogen here? 12. Because in glucose there are 12 hydrogens are present. So as there are 12 hydrogen atoms are present here, the atomicity becomes now how it becomes? So 18, because 18 grams of glucose by 180 into, in the place of atomicity what we should take here? 12 we should take. Don't take like 24, because the number of hydrogen atoms they are asking. So into Avogadro number 6.022 into 10 to the power of 23. So in that way we can able to calculate the number of atoms. Number of atoms, if they won't specify anything, what are the number of total atoms present in the species or molecule or compound, same thing you can take. Otherwise, if they specified one particular element, that particular atoms or that particular element, how many times it is given in that question, in the particular compound, you have to see, that is only its atomicity. That is how we have to do the atomicity related questions or number of atoms. Now let me take with respect to number of electrons. Number of electrons, how to calculate? So number of moles into number of electrons in that species into what? Na. Let me consider here. So I have taken for example some O22 minus. O22 minus. Okay, O22 minus is a particular species which is present here. How many number of electrons are present? How many number of electrons are present? If let us suppose some say some 5.6 liters is provided to you. Some 5.6 liters if it is provided here, how many electrons are present in that particular species? Let us suppose 5.6 liters in this sense volume they provided to you, So what you should do here? Now number of moles. Number of moles how to calculate here? 5.6 by 22.4. 22.4 into number of electrons in that species. Number of electrons in that species in this sense what here? In O2 molecule, actually O2 in this sense atomic number we have to take, because number of electrons is nothing but you can say atomic number if it is a neutral atom. Correct. But it is an anion. As it is an anion, extra electrons also will going to come, right? Therefore, first let me take number of electrons present in O2. So as oxygen atomic number is 8, 2 16. 16 plus 2. Extra 2 are there here. 16 plus 2, 18. Therefore, I can take 18 electrons. 18 electrons are present in this particular species. Into Avogadro number 6.022 into 10 to the power of 23. So in that way, number of electrons can be calculated if 5.6 liters of O22 minus species is given. Here, what is important? What is a given data is important. Given data, whether they may give you in the form of like here volume or particles or mass. With the help of that, number of moles can be calculated. Then, what they are asking, whether specifiedly they mention a particular atoms or overall atoms. And next, whether they have taken a particular species. It may be cation, it may be anion, it may be a neutral molecule. Anything they may have given to you. So when neutral atom is given or neutral molecule is given to you, just you can add atomic numbers. All the atomic numbers of the particular elements what they provided to you in the compound, if you can add, we're going to get total number of electrons. Okay. And into that if you can do, you'll get the answer here. Okay. And in this case also there are second type of category where specified, they're going to ask you specifically one particular atom if they'll provided to you. For example, in the place of like O22 minus, if I can take for example some H2O, I can take it. Just I have taken, let us suppose H2O. In that H2O, if they'll ask you same, let us suppose 5.6 liters of like H2O is given to you, and how many hydrogen electrons are present in that? How many hydrogen electrons are present in that? So at that time what we should take here, number of electrons with respect to hydrogen only we have to consider. That means with respect to hydrogen, how many electrons are there in that here? Only 2 are there. Because atomic number will be 1 plus 1, there are 2 electrons are there. So in that particular species, instead of taking this 18 of this H2O, what we should take here? Only 2 we should take here into Avogadro number. That is how we have to do this particular questions. Therefore, in mole concept, actually concept is very, very easy. there are three categories they are going to provide it to you, only mole related. So later and all we have so many different categories are there here, but basic level, this is all basic level we can say. Mole, how to calculate mole? Okay, with respect to mass, with respect to volume, with respect to particles, how to proceed. That and all we have to calculate here. Okay, first category will be direct formulas. Second category, to link. Third category, by using these and all here, next category is how to proceed, like number of molecules, number of atoms, number of electrons, that is species and all here, how to proceed. So this is how like we have to proceed with respect to problems in the mole concept here. Okay, now let me take one more simple another concept. Let me take one small concept, what you can say, percentage composition. What is percentage composition? Percentage composition is nothing but you can say a particular atom, how much percentage is present in the given compound. So for example, let me take H2O. H2O, if you can consider here, H2O, what is the molar mass? Molar mass of this is 18. Okay, so just imagine this 18 grams, if you can assume it as 100 grams. If it is can assume as, or you can able to extend to 100 grams. Actually in that 18 grams, how many grams of hydrogen and how many grams of oxygen is present here? Hydrogen is actually 2 grams and oxygen is 16 grams. Okay, the same hydrogen and oxygen with respect to 100 grams, how much it is present? How much it is present? That is actually called as percentage composition. Percentage, percent, in the sense like 100. We are taking the reference as 100. Okay. So with respect to 100, what is the individual quantity in that? So how to proceed, how to calculate that? So let us suppose here, a formula to calculate percentage composition is percentage composition is equal to okay, so the mass of a specified atom or specified atoms by the total mass which is nothing but you can say molar mass into 100. For example, let me calculate with respect to hydrogen. Let us suppose here hydrogen percentage, if I want to calculate in this. So mass of specified atom, that means in that H2O, how many grams is there here actually? 2 grams is there. So 2 grams by, what is the molar mass of H2O? 18 into 100. If you do, you'll get the answer. Similarly, oxygen percentage, if you can calculate, oxygen is how much? Oxygen is 16 grams. 16 by 18. Total molar mass is 18 into 100. If you do, you'll get the answer. So this is a particular formula to calculate percentage composition. Percentage composition. But what is the meaning of that percentage composition? This is the meaning. You are extending that particular small weight with respect to 100 grams. 100. That is actually percentage composition. Now, say for example, only 2 elements are there in this. So let us suppose in water, hydrogen and oxygen is there. So when you are doing one particular percentage, something you got X percentage you got. Okay now. So second one, you no need to again calculate with by using the formula. Directly we can also do, how to do here, oxygen percentage is equal to 100 minus X percentage. Oxygen is equal to 100 minus X percentage. Why? Because only 2 elements are there, right? In the 2 elements, so one if it is X percentage, remaining will be 100 minus X only, no? Because both together should equal to 100% we should get here. So in that way, percentage composition can be calculated. Percentage composition is nothing but, it is a quantity of a particular specified elements with respect to 100. Okay, that is actually called as percentage composition. And with the help of this percentage composition, we can able to calculate empirical formula and molecular formula, and that related concept is also there actually here. Okay, so formula to calculate percentage composition is the mass of specified atoms by the total mass into 100. That is how like we can able to proceed with respect to percentage composition here. Okay, so this is about the particular topics, mole concept and percentage composition. Thank you.